Welcome to the first video in Discrete Math 2. This is a continuation of Discrete Math 1 on my YouTube channel, and this course will cover the inclusion-exclusion principle, basic discrete probability, some generating functions, recurrence relations, and the beginning of graph theory. So we have to start off with one video on counting review. Instead of having to watch 5 or 6 in the first series, I'm just going to bunch it up into one video here, and we need to understand the basics of counting because we need it a lot, very important for inclusion, exclusion, and probability, but it also relates to generating functions and recurrence relations. There's a little bit of graph theory counting, but it's not the focus. So let's begin. We're just going to do some practice questions, and hopefully the theory will jump back to your head. If not, I have videos in Discrete Math 1 explaining all the principles. So, how many ways can you arrange the letters in the word tails? So, we have 5 letters, T, A, L, E, and S. We can swap letters around and have new order. For instance, A, T, E, S, L is a method. So what we do is we take our first position and we say there's 5 ways to do the first letter. There's going to be 4 letters remain for the second position, 3 ways for the third, 2 for the fourth, and 1 for the last. So this is 5 times 4 times 3 times 2 times 1, which is equivalent to 5 factorial. So again, we can pick L for the first one. That means in the second spot we only have A, T, E, S, so we pick S. Then we have A, T, E, so we pick E. Then we have A and T left, so we pick A. And then we can pick T for the last one. So this is permutations without repetition. Now we'll move on to another word, except this word is barbaric. So we have B, A, R. Except then we come to another B, so I'm just going to list that B below. And then we have another A, then we have another R, then we have an I and a C. So, this is a little bit different because, well, first of all, let's order them. So we have 8 factorial spots to fill. But the B's are similar, the A's are similar, and the R's are similar. So this means if we make, say, B, B, A, R, R, I, C, in this case, we might have one alteration where this is B1, B2, and we might have another one where this is B2, B1. So we're counting every pair of B's twice. So we have to divide by 2 factorial for the B's. There's also going to be situations where we're counting the A's twice, so we divide by 2 factorial for the A's, and we divide by 2 factorial for the R's. So we get our final answer here of 8 factorial over 2 factorial times 2 factorial times 2 factorial. Now, we can write this as a multinomial coefficient, so we can write this as 8 with 2, 2, 2, 1, 1, and that can be represented the same way, since we're really also dividing by 1 factorial i's and 1 factorial c's. Except there's only one of them, and 1 factorial is just 1, so we leave it out of the denominator. But it's good to mention that, really, in this previous question, it's 5 factorial over there's 1t, 1a, 1l, 1e, and 1s, but that's not necessary. So that is another permutation question when we have repetitions in them. So here's a fun question, and this is pretty important. Lattice paths are interesting, and this question is sort of crucial to a topic coming up in the next video. So this is a grid, and we want to go from point A to point B, going only north and only going east. So we start here at 0, 0, and we need to go 1, 2, 3, 4 to the right, and 1, 2, 3, 4 up. So we're going from 0, 0 to 4, 4. Okay, so this is kind of like making a word. So when we go 4 to the right, what we're doing is we're going east, 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 and then we need to go north 4. So we have n, 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 n. And we can rearrange these so we can get a different path. So for instance, I have northeast, north, northeast, northeast, east. So let's draw that one. We go north, we go east, we go north, north, east, north, east, east. So that's a path. So what we can do is we can just figure out how many ways we can arrange these letters so that they're distinct paths. Well, we have 8 total letters, so that's 8 factorial over, well, we have 4 n's, so we divide by 4 factorial, and we have 4 e's, so we divide by 4 factorial. So this is the solution from 0, 0 to 4, 4. Okay, so that's one specific example. Now let's make this a little bit more general. So we want to go from AB to CD. Okay, so that means we pick some arbitrary point AB, and then there's some point somewhere else, CD, and we want to know how many ways we go up and how many ways we go right. So we can do this using any method we want, pictorially, but really, what's the distance we're changing in x values? So the x value is going from A to C. So the distance is C minus A for the x's. We'll call that delta x. Our change in the y directions, how many ways we go north, we go from B to D. So the change in y is going to be D minus B. So we're going C minus A to the right and D minus B to the north. So how many total ways, or how many total moves are there? How many total norths and easts are there? Well, there's going to be C minus A moves to the right plus D minus B moves north. So that's the total amount. So that's our factorial, C minus A plus D minus B factorial. And then we want to divide by how many of the same letter there are. So there's going to be C minus A easts, and there's going to be D minus B norths. So this is the solution to the general question. This may look a little bit confusing, but we can just say that M is equal to C minus A, N is equal to D minus B. So this is our delta x here. This is the, actually I should write down the number of easts and the number of norths is equal to M. So this is really just M plus N factorial over M factorial N factorial. And this is a general equation you can use for any lattice problem. In fact, even if what we're doing is we're going from AB to CD going down and left, we'd still get sort of a proper answer. Of course, realistically, we know that the answer is 0 if we're going down to the left. But you know what? Play around with it, see what happens. So that is some more permutations with repetition. What's interesting about this is that this can actually be written as a combinatoric problem, where it's M plus N, choose M. Or we can write M plus N, choose N ways. That's the same thing. Alright, so here's a nice combinatorics problem. So a student must answer 7 out of 10 questions on a test. How many ways can he do this if there are no restrictions on which questions he answers? Well, there's 10 questions total, and he has to answer 7 of them. So let's just 10 choose 7, which, if you don't remember the formula, this is 10 factorial over 7 factorial over 3 factorial. So if we have n choose k, this is equal to n factorial over k factorial times n minus k factorial. It's the same thing. So n over k is the same thing as n choose n minus k, because if you expand it out, you'll get the exact same equation. So this is an important thing to remember. So if you can remember this and put this in your memory forever, you're going to be a lot happier on your exams if you take this course in real life. Okay, so what about if the student must answer the first 2 questions? Okay, so what this really means is that he's taking the first 2 and he's choosing both of those. And then he has the remaining 8 questions, and he has to answer 7 of them, but he's already answered 2, so he has to pick 5 of the remaining questions. So 2 choose 2 is the same thing as 1. So this is 1 times 8 choose 5. So it's really just a question of saying how many ways can he answer 5 questions out of the last 8. So this would be 8 choose 5. Now what if he must answer at least 4 of the first 6 questions? Well, what this means is that he can choose 4 out of the first 6, and then he can choose, out of the remaining 4, he can choose 3 questions. So basically he's splitting it up into 2 categories. Here's 6 questions, the first 6 questions, and here's the remaining 4 questions. This one he picks the first, the second, the fourth, and the fifth, and then in the second part he picks the 8th, the 9th, and the 10th. So those are the questions he could answer. So we multiply them because the order could change, or not the order, but the selection could change for the last 4 questions. So instead of 8, 9, 10, we might have 7, 8, 10. So this is why we multiply. Now the question didn't ask if he only answered 4, they said at least 4. So we also have to add the situation where he answers 5 out of the first 6 questions, which means he only answers 2 out of the remaining 4. And then if he answers all 6 of the first 6 questions, then he can only pick 1 out of the last 4. So this would be your solution to answering 7 out of 10 questions if he must answer at least 4 of the first 6. Now we can write this a little bit neater, a little bit more complicated, I guess. We could write this as the sum as I equals 4 to 6 of 6 choose I times 4 choose, how do we want to do this? If I is equal to 4 and it's going up, then we want to do this like, I might want to pick better numbers here. Let's pick I equals 0, and we'll go 6 choose 4 plus I, 4 choose 3 minus I. That looks a little bit nicer, and this will be I equals 0 to 2. So, I mean, even for me, this takes a little bit to figure out, oh, how do I write this in sigma notation? But this is just equal to this. And you're going to be seeing a lot of sigma notation in this course, so you might want to get used to this. I'll probably reintroduce it when I need to, but this is just a nice, concise way of writing this answer. Alright, now we've dealt with combinations without repetitions, so let's jump into combinations with repetitions. Here's a question I did, and I even put on the practice, or my own final that I wrote for the first course, which you can do at TrevTutor.com. If you go to Discrete Math, there is a final for Discrete Math 1 that I made with a solution key. So here's a question that was similar to one on there. How many integer solutions are there to x1 plus x2 plus x3 is equal to 12? So what we're saying here is that we have 3 distinct bins. We have our x1, we have our x2, we have our x3, and we want to distribute 12 items into them. So the bin can have 0 or more items, so we might put, I don't know, let's put 1, 2, 3, 4, 5, 6 in x1. We put 2 in x2, and then we put 4 in x3. So that's one way that we can do it. So here's the question. Now, how do we do this into a combinatorics problem? Well, what we do is we line up 12 items. So there's 6, 7, 8, 9, 10, 11, 12. And what we do is we insert separators. So because there's 3 bins, we have to insert 2 separators. So we could put them here and here. So now, this right here is our x1, this is our x2, and this is our x3. Now, what we can also do is we can put them both, say, here and here. So we have nothing in x1, nothing in x3, but we have everything in x2. So really what we're doing here is we're not picking 12 objects or choosing 12 objects. We're actually looking at 14 spots, and we're going to put a divider into 2 of them. So this is actually equal to 14 choose 12, or I should say 14 choose 2, because we have 14 spots, and we are putting in 2 dividers. So there's another way to look at this, and that would be that we have 3 bins plus 12 objects. We subtract 1 from the amount of bins we have, and we choose 12 of them. So this is the same thing. This is 14 choose 12, which is the same thing as 14 choose 2. And I'll give you a general formula for this because it's very important to have the general formula if you don't understand the ideology behind it. And that is if we have x1 plus x2 plus all the way to xn, and we choose k objects, then this is equal to n plus k minus 1 choose k, which is the same thing as n plus k minus 1 choose n minus 1. So that's 2 ways of looking at things. Our n in this case was 3, our k was 12, and we subtract 1, so we get 14 choose 12. That's what I taught in the first video on combinations with repetition. What I didn't teach, and I put on the exam anyway because I'm mean, is what happens when we require that certain bins need 2 objects. At least 2 objects. Well, we make some substitutions. So we're going to say that x1 prime is equal to x1 plus 2. So we're just going to rewrite the problem. We want to shift it to an equation where xi is greater or equal to 0, because we know how to deal with that. So we're just going to redefine the variables and make that a problem. So this x1 can be 0 or greater, and it's going to have at least 2 in x1 prime, because we're adding 2 to the bin. We can do this with x2 prime, so this will be x2 plus 2, and x3 prime will be x3 plus 2. So we could rewrite this equation here. So we have x1 prime plus x2 prime plus x3 prime is going to equal, well, I should write this, we have 12 here, but we have a plus 2 here, so we're going to have to subtract it from that, because x1 prime is x1 plus 2, but we only have an x1 up here. We're missing the plus 2, so we subtract it from the right side. And similarly, we do this with the other 2. This will be minus 2, minus 2, minus 2. So then we get x1 prime plus x2 prime plus x3 prime is equal to 6, where all of our xi primes are greater or equal to 0. And now we just solve in the exact same way. We take, well, there's 3 bins, and we're choosing 6. We subtract 1, and that's choose 6. So this is equal to 8 choose 6. Or similarly, 8 choose 2. Same problem. We've just redefined some variables a little bit. You'll be seeing this when we do inclusion exclusion, because there's some good questions you can do with this. So keep this one in mind. And finally, we just had some integer solution problems, but we can also have word problems that are combinations with repetition. So how many ways can we put 8 white balls into 4 distinct containers, where none of them are empty? Well, we have 4 distinct bins, so that's our x1 plus x2 plus x3 plus x4, and we have 8 balls to distribute. So this is just this equation, and we know how to solve this equation. It's going to be 4 plus 8 minus 1, choose 8, which is the same thing as 11 choose 8. What's important to remember in this example was that none of them are empty, so our xi's are greater or equal to 0 here. This one's a little bit more challenging. So we have the same equation here, x1 plus x2 plus x3 plus x4 is equal to 8, but we have a restriction. x4 has to be an odd number. So x4 is going to be 1, or it's going to be 3, or it's going to be 5, or it's going to be 7. So we have 4 questions to solve here. So we have the case where x1 plus x2 plus x3 plus 1 is equal to 8, because x4 is 1. We have the situation where x1 plus x2 plus x3 plus 3 is equal to 8. Then we have the situation where plus 5 is equal to 8 and plus 7 is equal to 8. So we have to add all these up separately. So this just becomes x1 plus x2 plus x3 is equal to 7, which we know the solution by now. I'll just do it shorthand. So 3 plus 7 minus 1 is 9. Choose 7. This one is going to be x1 plus x2 plus x3 is equal to 5. So 3 plus 5 minus 1 is 7. Then we choose 5. And by now you can probably see the pattern, so you can guess that the next one is going to be plus 5 choose 3, and then the last one is plus 3 choose 1. And that would be the solution where the last bin has to contain an odd number. You can verify these yourself, but normally if you see a pattern like this, it's probably right. Alright, so that was the counting review. If some of these concepts were a little bit confusing, you can either leave a comment below and I'll answer it the best that I can. You can check the website TrevTutor.com and you can check out Discrete Math 1, and there will be some explanations on some of these concepts in those videos. You can also do the practice final I wrote and check out the solutions for that. And another way, you can just email contact@TrevTutor.com. Any way to figure out these problems, because these are the fundamentals of the course, so if you don't understand the fundamentals, you're probably going to have a little bit of difficulties understanding the problems later. So that is the first video. Next time we'll introduce a new concept that is going to rely on the notion of a lattice path. It's going to be kind of fun. So I'll see you guys then. Thanks for watching. If you liked the video and helped, subscribe, tell your friends, share it. That would be awesome. Thanks.